Okay, so last one I'm going to do for now is question number 42. It says the height of a rectangular box is 10 inches. The length increases at a rate of 2 inches per second. The width decreases at a rate of 4 inches per second. The length is 8 inches and the width is 6 inches. First of all, I'm going to just draw the box. It's got a height of 10. Okay, it's pretty high, I guess. It's got a width of 8 and a length of 6. Okay, sorry, the length is 8 and the width is 6. Okay, so length equals 8, width equals, and that's my height. Okay, so it tells me that dl by dt, the length is increasing, I think, yeah, at 2 meters per second. The width is decreasing at 4 meters per second, or feet per second. And we want to know dv by dt. We don't know that. So we need to connect length with height with volume. Well, the formula for the volume of a cube is length times width times height. Since the height is fixed, I'm just going to replace that with 10. So I end up with 10 LW. So there it is. I have my LW dl by dt, dw by dt, and I just have to figure out dv by dt. So at this point, I just need to differentiate this with respect to time. Since this is a product, I need to apply product rule. So the derivative of L is dl by dt times the width plus L times the derivative of W is dw by dt. Okay, so there we go. So I have all these parts. These are all parts that are given to me, so I just need to plug it in. This is 2 feet per minute times the width is 6. Okay, so which makes sense because this is essentially the change in area, right? So the change in length per times width, which gives me area, and this is change in length times change in width, which is also area. So length is 8. dw by dt is -4. Okay, so in this case, I end up with this volume is actually decreasing. That's going to be -32 plus 12 is -20. So it's decreasing at a rate of 200 cubic feet per second. Okay, and looking at the answer key here, it looks like the answer is -200 or D.